The Effectiveness of Activated Carbon Filters by Joseph Melvin. Carbon absorption filters force water through a carbon absorbent medium that attracts gases, liquids, or other particles that are floating in the water. The purpose of my experiment was to determine the effectiveness of activated carbon filtration on varied water samples. As noted in my research, absorption efficiency of activated carbon filters is dependent upon the pore size and surface area of activated carbon. My hypothesis stated, if there is more surface area present in an activated carbon filter, and therefore more capacity to collect and clear pollutants from the incoming water source, the cleaner the resultant water supply will be. I analyzed 5 different types of activated carbon filters. The Cuisinart coffee filter with the smallest surface area encased in permeable fabric, the Camelback water bottle filter with a smooth cylindrical carbon surface, a medium-sized fish tank filter with loose carbon granules encased in fabric, the Brita water filter with loose carbon encased in a thin fabric and a plastic outer shell, and the largest filter, the Whirlpool inline refrigerator water filter with a solid carbon filter enclosed in a mesh casing. I tested for the following contaminants: chlorine, bacteria, lead, nitrates, nitrites, iron, copper, and pesticides. All samples tested negative for nitrites, lead, and pesticides. The creek water was the only sample that tested positive for bacteria. All subsequent testing was performed for initial positive results only. Each sample was placed in a test file, poured over the specific activated carbon filter, and retested and compared against original positives. I believe my hypothesis was supported in that the larger filters produced cleaner results. The larger Whirlpool filter had more clear pollutants from the water sample. The results of this filter produced clean water for all 5 water samples, with the exception of the repeated test for copper. A plausible explanation for that may be the quality of the test strip or a misread result, where I may have interpreted a negative test as positive due to the faint color change. I found that the compact surface of the Whirlpool and Camelback filters, compared to the loose activated carbon in the Cuisinart coffee filter and the fish filter, were more effective in removing the bacteria and the iron. This is an important feature because the Camelback is frequently used outdoors, where there may not be any clean treated water supply available. Even though scientifically there would be more surface area to the loose granules of carbon, they are restricted within the fabric and the total exterior surface area. The Brita bacterial result was the negative, but not as absolute, faint purple versus deep purple as the Whirlpool and Camelback results. I also analyzed the internal carbon surface area of each of the filters. The only residue or particles that could be seen adhered to the carbon were from the pond and creek water. Chlorine is usually added to the public drinking water supplies because it is an excellent disinfectant and kills bacteria. The chlorine levels were reduced in all samples, but remained present in the creek and pond water. Errors in my experiment could be a result of using different test strips with different parameters, the water supply or the activated carbon filters. Even though the filters were rinsed and dried before use, some carbon residue could have been present in the test sample. This would yield a false negative result, particularly in those with granular carbon. To improve upon this experiment, I would extend the water samples to known contaminated water supplies. Ensure all testing supplies are from the same manufacturer. Utilize larger water samples for a true representation of the original supply. And use a catch basin similar in size to the filter to prevent any runoff of unfiltered water into the test sample. Future experiments may also include designing a small activated carbon filter with a solid, compact surface area equal to the capacity and effectiveness of a large filter. It can be housed in a durable, moldable casing versus plastic to give it greater versatility, particularly in household products. That concludes my presentation. Thank you for listening.